Okay, in example 3, it says to use the idea of decomposing fractions to simplify and rewrite. What does it mean, decomposing fractions? Remember, to decompose is for something to fall apart. So we're going to take apart these fractions. So let's start out looking at A. A tells us we got cosecant of theta over sine of theta. Well, remember, this is the same as saying cosecant of theta times 1 over sine of theta. Now, there's different routes you can go here. It's up to you. There's not necessarily one direct route to get an answer, okay? So, usually my favorite, personally, is if I'm not sure what to do, I change everything I can to sine and cosines, because then I can always change them to their reciprocals if I need to. So what I would probably do here is, I've got cosecant of theta. And I know cosecant is 1 over sine of theta times 1 over sine of theta, which, remember, you multiply fractions straight across, so 1 times 1 is 1 over sine times sine, which would be sine squared of theta, but that's a reciprocal identity. 1 over sine of theta is equal to cosecant of theta, so 1 over sine squared of theta will equal cosecant squared of theta. And I've got it down to that. I just got one term there, so that's as far as we can go. It's about as simple as we can get. Alright, so let's look at B. B has sine of x minus cosecant of x all over cosecant of x. So what if first I separate this? Because this had to be a common denominator for both parts in the numerator, okay, for each term in the numerator. So I'm going to take and separate this into sine of x over cosecant of x minus cosecant of x over cosecant of x. Well, then let's look at this top part. The first part here. So I'm going to do what we did in A. So sine of x over cosecant of x is the same as saying sine of x times 1 over cosecant of x. And then we have our minus, well, cosecant of x over itself is just 1. So if I keep going here, we've got sine of x times 1 over cosecant of x is just sine of x. And then I got minus 1. And you got to remember PEMDAS. PEMDAS says to multiply, so sine times sine is sine squared of x minus 1. Now, when I see a trig function squared and a 1 involved in it, I think about my Pythagorean identities. Now, most of the time they'll work, but not every time. So let's check this one out. So the Pythagorean identity that has a sine squared and a 1 in it is the one that says sine squared plus cosine squared, or I should say sine squared of x plus cosine squared of x equals 1. Now, if I wanted to get sine squared of x and sine squared of x and 1 on the same side, I would have to subtract this. And so this would give me that cosine squared of x is equal to 1 minus sine squared of x. Is that what I have right there? Well, no. My 1 is negative and my sine squared is positive. So, as far as simplifying, this is simplified with what they gave me, but it's not as simplified as it can go, because I do notice that my signs are both different, aren't they? So what if I divided everything here by negative 1? And so if I do that, I get negative cosine squared of x equals negative 1 plus sine squared of x. I'm sorry, I'm writing into the thing on the side there. Now let's check, is this the same? Well, yeah, my 1 is negative, my sine squared is positive, so I could actually keep simplifying this, and this is equal to negative cosine squared of x.